So we're looking at basically applications of our derivative tests. So I've pulled some of the old AP free response questions and pulled some of the parts where we have to use that idea. Okay, so for instance, this right here. They've given me a picture of the graph of f, and it says the figure above shows the graph of a piecewise linear function f between -4 and 12. The function g is defined by the fact that g prime is f of x. So this graph that they've given us is the derivative of g. Okay? So it's asking, does g have a relative minimum, a relative maximum, or neither at 10? Justify your answer. Well, if we were doing it algebraically, we would look at our first derivative test. And since we're talking about right here at 10, and we were doing our first derivative test, we'd look on this side, both sides. On this side, my function is negative. Here, my function is negative. So remember, this represents the derivative of g. So these are the slopes of g. Well, if this is my critical point at 10, my slope on one side is negative, which means my function is decreasing. So I'm going to write over here. So if I'm looking at 10, that's my critical point. And on this side it's negative, and on this side it's negative. That means that my function goes from decreasing on this side to decreasing. So basically it has neither, because since it doesn't change signs from either positive to negative or negative to positive, we have neither a maximum or minimum. It's actually called a saddle point, so we have to justify our answer. So basically you're going to say exactly what you said, that this is the g of x has neither a max or minimum at x equals 10, since g prime of x equals f of x, and f of x goes from negative to negative. And basically we just wrote down what we just said. Okay? Now, part B. Does the graph of g have a point of inflection at x equals 4? So now we're right here at x equals 4. So this is part B. Does it have an inflection point there? Well, for this to be an inflection point here, that means that we got to think about it in terms of our second derivative. So normally we would look at our second derivative test and say, okay, if it goes from positive concavity to negative or negative concavity to positive, we'd have a point of inflection. But since we don't have the second derivative, we've got to do it based on my first derivative. And basically when my first derivative, f of x, is increasing, that means my second derivative is positive. And where this is decreasing, this is negative. So for there to be a point of inflection, my first derivative has to go from increasing to decreasing, or decreasing to increasing. Well, here my function is on this side increasing, and this side it is decreasing. So that is definitely a point of inflection, and that's what you're going to say in your answer, part B. You're going to say g of x has a, I'm just going to abbreviate, point of inflection at x equals 4, because g prime of x or f of x switches from increasing to decreasing. And that's it. That's all you have to put. That's how you know. So again, we're just using our first derivative test and our second derivative test together to answer this from a graph. And this is something common that the AP test does, where they give you information either as a graph or as a chart, and you have to figure out what it's asking you to do. Okay? Now, the second part. Okay? They give us this chart. It says the height of a tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Select values of h of t are given in the table above. Okay? So this is basically the height of a tree. So this chart, this is our height, and this is how long or the time the tree is alive. Okay? So at 2 years, the height of my tree is 1.5 meters. Okay? That's all this is telling us. It gives us the height at certain times. It says use the data in the table to estimate h prime at 6. Use correct units. Interpret the meaning of h prime at 6 in the context of the problem. So as soon as you hear this term estimate, and this is asking us to find h prime of 6. So h prime is basically the derivative. Well, it's asking us to estimate the derivative. The derivative is slope. So it's asking us to estimate the slope at 6. Well, at 6 years, where is that? Well, that's in between here and here. So basically, we're going to try to find or estimate the slope between these 2 points. Oh, slope between 2 points? That means that we're using the slope equation. So basically, part A is saying that h prime of 6 is equal to h at 7 minus h at 5 over 7 minus 5. It's our basic slope equation, y2 minus y1 over x2 minus x1. And since we're trying to estimate it at 6, we use in between 5 and 7, because 6 years is in between 5 and 7. It makes sense that that's what we're doing. So now we just plug in our values. Well, h at 7, that's 11 minus 6 over, and then 7 minus 5 is 2. So this is 5 over 2. Okay, so that is basically our rate of change for our tree. Okay, so this is our rate of change for the tree. It's how my height of my tree is changing over time. So the second part says explain the meaning of h prime of 6, and that's what we're going to say. We're going to say h prime at 6 is the rate where the height of the tree is changing in meters per year at t equals 6. That's it. So that's explanation. It's basically saying it's the rate of change, how my tree is changing in meters per year. Okay, because literally this is 5 meters, that's the change in meters, and this is your change in time per year. So meters per year. That's it. So it makes it sound like it's a really difficult problem, but you just have to find the keywords and pick out those definitions. Okay. Now, part B, explain why there must be at least one time t between 2 and 10 such that h prime of t equals 2. So again, they're saying, all right, there's got to be one time in between 2 years and 10 years that h prime of t equals 2. So what's h prime of t? That's the rate of change. This is what we just said. H prime is the rate of change, the meters per year. So is there a time between 2 and 10 where that change is 2? So it's basically asking us slope. So if we look here, this change is 1 year, this change is 2 years, 5 to 7, that's 2 years, 7 to 10 is 3 years. So we're basically doing like old stuff we did in algebra. So this change here is 0.5, from 2 to 6, that's 4, from 6 to 11, that is 5, and from 11 to 15, that's 4. So we look, remember, rise over run. So 0.5 over 1, that is 0.5. Well, that's not 2. Here is 4 over 2. 4 divided by 2 is 2. So this right here, between 3 and 5, my average slope is 2. Okay? Between here, it's 5 over 2, which is 2.5, and here it's 1 1/3. So since I know that the average slope between 3 and 5 is 2, I know that somewhere in there the actual slope, the instantaneous slope, has to be 2. That is our mean value theorem. So part B is basically asking us to do the mean value theorem. And the mean value theorem says if the average slope between 2 points has to equal the instantaneous slope somewhere there. Okay? Because you can't get from one to the other without going through all the ones in between. So for part B, we say, you know what? If we look at h of 5 minus h at 3, the slope, the average slope, and that's what we're doing. This is average slope equals 6 minus 2 over 2, which is 2. Since the average slope between those 2 points is 2, okay, we can say because h of t is differentiable and continuous, and that is extremely important. Saying that it's differentiable and it's continuous, which means it has a derivative everywhere and there's no jumps or hole. So it's differential and continuous on the interval 3 to 5. So that interval that we're looking on, by the mean value theorem, and I'm just going to write MVT, there absolutely exists a value, we're going to say C, in between 3 to 5, where h prime of C equals 2. And that's it. So we're using the mean value theorem here. Okay? So the two main concepts are my average slope and the mean value theorem. And the mean value theorem literally says if your function is differentiable and continuous on a closed interval, and you know the average slope between those 2 points, there has to be somewhere in between there where the derivative equals the average slope. Okay? So you can see we're starting to put together a bunch of different ideas here. Okay? And you've got to make sure that you know these. And the mean value theorem specifically, you have to know that equation. And if you know it, you should be able to write it. And the mean value theorem says f of c equals f of b minus f of a over b minus a. And it's on that interval between a and b. So the mean value theorem says if this has to equal this somewhere, if you're on a closed interval.